So it says complete the statements about the graph of a function. When a graph is symmetric about the origin, it's a very specific type of function. Now, this is just something that you have to memorize. If you haven't memorized it, you should. But symmetric about a function means that it is just a odd function. So, oops, let me use my pen here. So that just means it's an odd function. If it's symmetric about the y-axis, then that means it's an even function. Now, what that means is that an even function, if you evaluate it, that's not really good. You can't really read that. An even function, if you evaluate the negative x value, it will equal the same as the positive x value. In other words, if I take a function and evaluate it at -3, it will equal the same y value as if you were to evaluate the same function at +3. I'll give you an example. Let's say that f of x is equal to x squared. Well, if I say f of -3, then that is going to be -3 squared, and that equals 9. If I say f of 3, then that would be +3 squared, and that's also 9. So this is an even function. Okay. Now, the other type of function is an odd function. Well, there's even, odd, or neither. So an odd function, if I put the negative in, I get a negative y value. So let's do g of x equals x cubed. So now if I say g of -2, I get -2 cubed, and that's the same as -2 times -2 times -2 times -2. Well, these become +4. +4 times a -2 is a -8. Now, if I say do the same thing with a +2 cubed is just 2 times 2 times 2, which is a +8. In other words, when I take the negative of the function, I get a negative y value. If I take the opposite, I get the opposite value. When I evaluate at -2, I get -8. Now, sometimes these flip-flop. There are even function or are odd functions that if I plug in a -2, I get a +8. If I plug in a +2, I get a -8. But it's always the opposite, right? So if I evaluate the opposite value of x, I get an opposite value of y. That's it on that one.